Hi and welcome to my video. A little while ago I did a video on the chain rule and showed how the equation shown here in yellow, well actually the one in yellow here is an extension, but how the chain rule could be pretty much explained, if not proven, by using a set of gears. The one in yellow here is an extension of the chain rule. Just to recap what I showed in the previous video, if we have three gears here, I've drawn them in blue, and we'll call them, we'll call this one X, this one U, and this one Y. And what I was able to show was that dy dx, which is the rate of change of the Y wheel with respect to the X wheel, equals du dx, which is the rate of change of the U wheel with the X wheel, multiplied by dy du, which is the rate of change of the Y wheel with the U wheel. So you can watch my previous video. I'll go into more detail exactly about how that comes about. What I want to show in this video is how the basic chain rule here can be extended by adding another wheel. I'll show this how this can be done. Let's just get rid of all of this here, and we'll continue on now by adding our new wheel. So put our wheel up against here, like that. Okay, so we'll call this wheel here we'll call X, and this is Y. And we have two intermediate ones. We have U and we will have V. Okay, so now the rate of change of U, which is just du, rate of change of U with respect to X, is here. We have the rate of change of V, dV, with respect to U, is here. And the rate of change of Y with respect to V is here. So we can actually say dy dx is equal to the rate of change of U with respect to X, du dx, multiplied by the rate of change of V with respect to U, dV du, times the rate of change of Y with respect to V, dy dV. So that's actually an extension of the original chain rule. The original chain rule, or the existing one that everyone knows, is dy dx equals du dx times du dy. So what I've actually done is just added an extra intermediate variable, if you like, into the mix. So how do we go about using this? Okay, well let's say we have the equation y equals sine of the natural logarithm of, say, x squared. Okay, so let's just clean that up a little bit here. Natural logarithm of. Okay, so what we do is first off we assign u. We'll assign u to be x squared. We start from inside, so we say u, let u equal x squared. So therefore du dx is 2x. So remember that one. Then we can say let v equal ln of u, because we've assigned u already as to be x squared. So that means dv du equals 1 on u. So remember this here. And lastly, we say y equals the sine of v. because we've assigned v above as being ln u. So that means dy dv equals cos of v. Okay, that's straightforward enough. So, what's dy dx? Dy dx equals, looking back at our formula up here, du dx. So du dx is 2x, so we have 2x multiplied by. The next one is dv du. So that's 1 on, and we know u is x squared. So we have x squared times dy dv, which is cos of v, and of course we know v is ln u, so that's ln, and u of course was x squared. Bit squashed here, sorry. Okay, so we can cancel this with this, so the result is 2 on x times cos natural log x squared. So there we go. I mean, there are other ways of doing it obviously, but that shows how this can chain rule can be extended. And of course you can add as many gears as you like and keep extending this ad infinitum. So I hope that's really added to the understanding of chain rule and how easy it is to apply it to your work. I hope it's helped people out there. Thanks very much for watching.